Good day everyone. Today I'm going to be discussing resin grouted bolting. Understanding resin grouted bolting. When rock bolts are installed, they modify the ground behavior and can prevent or restrict rock failure. They do this by transferring load from unstable part of the rock mass to the rock bolt itself and then into stable ground. The strength of the bond between the anchor and the rock is the measure of effectiveness of this load transfer mechanism. Adhesion plays no significant part in bond strength, and it is wrong to think of resin bonded bolts as being glued to the rock. Shear in the resin layer caused by rock or bolt displacement generates high radial stresses which act across the interface and maximizes the frictional resistance. Both the bolt profile design and rifling of the bore roll wall, as well as the properties of the resin, are important factors in generating this frictional resistance. The rock bolt function in a support system. It is the rock bolt which strengthens the rock. The function of the resin is to transmit loads from the rock to the rock bolt without allowing the rock bolt to move. The resin does this by filling all irregularities on the surface of the rock and the bolt. The two surfaces therefore cannot slide past each other, nor can the rock close in towards the bar. The rock is effectively locked into place by the resin and the rock bolt combination. Below is the illustration of the resistance zones, where the pink is illustrating the rock bolt. The resistance zone on the top side is the ribs on the rock bolt, and on the bottom side the resistance zones are the irregularities of the rock surface. The rock bolt function in the support system. It has been proved that some deformed bars do provide better mixing of the resin capsule, but some of the questions I would like to put out there is, what happens with horizontal force stress on the portion of the bar which has deformation or profile change, which normally occurs on the top part or the end of the bolt? Has there been tests to verify this on the deformed bars? The annulus in these areas would also vary. Is this of a concern to the users? Checklist for some possible bolting problems encountered underground. Bolts are falling out after the spin cycle or observation of the fall of ground where resin is still bonded to the bolt. Possible reasons: insufficient mixing occurred during the installation. The annulus between the rock and the bolt is too large. Movement of the bolt during the hold period, breaking the bond between the resin and the bolt. The bolt does not tension after the hold period has lapsed. This could be possibly caused by underspinning or overspinning during the spin time. Possibility of a cross-threaded nut on the bolt. Fast resin capsule was not inserted into the hole first. Resin capsule does not fit into the hole. It could be possibly caused by a wrong diameter capsule used, wrong drill bit that is used, the drill bit that is used is worn, the hole length is not correct, or there could have been strata movement preventing the capsule to be inserted into the hole. Low pull-out strengths could be possibly caused by hole diameter too large, the annulus, the hole drill is too long, insufficient resin in the hole, over or under spinning, cracks in the rock wall, loss of resin into the cracks that would cause you not to have sufficient resin in the hole, the incorrect bolt, or poor or expired resin that is being used. If there's excessive protrusion of the bolt from the hole, this could be possibly caused by the bolt that is too long, hole diameter is incorrect, the bolt can't be inserted right to the top of the hole, fast resin capsule not inserted into the hole first, it could be inserted second, thus as the bolt is busy penetrating, the resin is busy setting, and the bolt cannot be pushed to the back of the hole. Old resin, the viscosity is too thick, or expired resin, which will create further resistance for being able to push the bolt to the back of the hole. Insufficient thrust by the bolter during the installation. Low air pressure where handheld equipment is used. This would be caused by this will cause insufficient thrust and ability to push the bolt to the back of the hole. In installations, shortcomings, the do's. Do ensure all personnel performing the installation is familiar with the task and ensure there is training taken place with the operators. Do use information supplied on the resin package, for example, the spin and hold times. Roof bolting systems are designed by both rock engineers and the supplier. These will vary from other users because of different underground conditions. The basics, however, remain the same. Do include suppliers in your design process. Do quality audits on suppliers. Although there are still some taking place, it appears to be something not occurring on a regular basis. Do you use the correct equipment prior to commencing with installation? Ensure appropriate PPE is supplied to the operators. Barring has taken place. Work under supported roof at all times. Check bolts and resin supplied to the work area and that they are the correct items. Do install to the standards as documented. Example would be the hole length, hole diameter, and bolt diameter, etc. Do ensure the drill rig or handheld machinery are functioning correctly. To ensure that the load indicator has collapsed after tightening the nut, ensuring load is applied to the bolt. If the resin installation requires more than one capsule, do ensure all capsules are inserted into every hole. Do ensure that the product specifications required by the design process is part of the product specification in a tender process. Do perform regular tests and inspections on installations. Installations, shortcomings, the don'ts. Do not discard any safety standards during the installation. Do not take any shortcuts in the installation process. Time is money, but in this process, time can save lives. Wait the whole time before tightening the nut. Do not spin the bolt longer than the recommended spin time. Do not insert the incorrect amount of resin capsules or in the incorrect order of resin capsules into the hole. Do not use any damaged or expired resin capsules in an installation. Do not use any bent or damaged bolts in the installation. Do not move the bolt during the hold period. Do not leave resin capsules on top of drill rig engine compartments during installation. The engine compartments will create excessive heat which would be transferred to the resin capsules. Do not store resin capsules close to any heat source. Store resin capsules in well-ventilated areas underground. Thank you. And if there are any questions,